Hello everyone, my name is Jessica and I will be using GSP to create an interactive model to find Euler's line. The mathematical goal for this activity is to have students see the relationships between three of the centers of a triangle, which are the orthocenter, the circumcenter, and the centroid, by constructing them on GSP to make Euler's line. The technological goal of this lesson is to create a dynamic model in which students can investigate the geometric properties and relationships of the three centers by manipulating the shapes to come to their own conclusions. The pedagogical goal is for students to interact with the construction and discover the relationships on their own rather than reading about the relationships out of a textbook. Before going ahead and discussing the questions I would ask during my lesson, I would like to take you through how I would go about teaching this lesson. First, I would have all students create their own models by using Sketchpad to make a triangle. Then I would have them construct the centroid, the orthocenter, and then finally the circumcenter. To construct the centroid, they would have to find the medians of all the side lengths of the triangle, as you see here marked with the yellow points, and connect those medians to the opposite vertex. So F would go here, B would go to this median, and E would go to this median, like so. The centroid would be constructed by the intersection of all of these lines. So that is the centroid. The orthocenter is constructed by finding the altitudes of each of the sides, like so. And again, the intersection of all three lines is the orthocenter. Oops. The circumcenter is found by finding the perpendicular bisectors of the three sides. And the circumcenter would be where the three lines intersect. After students have constructed the models on their own, I would have them work in groups so that they can work together on coming up with conjectures on the relationships between the centroid, the orthocenter, and the circumcenter. Before constructing the Euler line, I would ask them during the class what they noticed about the centers as they manipulated the triangle. Are the centers always inside the triangle? If so, which ones? Where are the centers when you construct an acute triangle? And where are they when you construct an obtuse triangle? What do you notice about the three centers, and is there a relationship? I would also ask what the relationship between the distance from the orthocenter to the centroid versus the distance from the centroid to the circumcenter. As the lesson would come to an end, hopefully I would have guided my students into concluding that the circumcenter, the centroid, and the orthocenter all connect to make the Euler line, which is in red. We would then hopefully have concluded that the distance between the orthocenter and the centroid is twice as much as the distance between the centroid to the circumcenter. And we would have come to that conclusion by measuring both distances, which we can see here, that the orthocenter and the distance from the orthocenter to the centroid is twice as much as the distance from the centroid to the circumcenter, and it doesn't matter how big or small the triangle is.